Here is our review video that I promised you guys. So I told you to check wits. Hopefully you guys find this so that you can use it to help you study for your test on Thursday. Things I'm going to cover in this entire exponent section I think we need to review. And then I picked out a couple polynomial problems with simplifying, some with some brackets. Definitely going to do some cube root stuff with the conjugate down here and creating a perfect square in the denominator when you're rationalizing. Proving a polynomial identity. Division, you guys are pretty good on, so the key will be up so you guys can check those. Remainder theorem problem. And lastly, finding the value of k so that this polynomial has a remainder of 44 when divided by x minus 2. So just so that you know what to look forward to in the video. So I'm going to start with the exponents. This is our weakest spot. A lot of questions that I've been getting are us not remembering just our exponent rules. If you have two numbers being multiplied and they have the same base, that's when you add your exponents. So this is 2 plus 2, so this is x to the fourth. If I have a power to a power, this is when I multiply, and that's because this means x squared times itself 3 times. Whoops, times itself 3 times. So 2 plus 2 plus 2 gives me 6. So it's x to the 6th, and 2 times 3 gives me 6. So that's why. Okay, so coming down here at the first one, I have a product of a power. So this times itself 6 times, or what we learned in class is you can take this 6 and distribute it to each exponent. And we're talking about distributing, we're saying multiplying, not adding. So this becomes 2 to the 6th, x to the 18th, and y to the 6th. And 2 to the 6th is 64, so I have 64, x to the 18th, y to the 6th. And I can only distribute this exponent because it's a power of a product. These are all being multiplied together. If there was an addition sign in there somewhere, I could not do that. This is power of a quotient, so it operates the same way, but you're doing it to the denominator as well. So this is 3 to the 5th. Don't forget the coefficient here. He has an exponent of 1, so that gets multiplied as well. X to the 20th, all over y to the 30th, and I'm multiplying. 3 to the 5th is 243, so 243x to the 20th divided by y to the 30th. And that is completely simplified. Okay, I've got a power of a product again, so I'm going to distribute this 8 to each exponent. So I have x to the 16th, y to the 32nd, and m to the 24th. Okay, and that's also simplified. I can't combine x, m's, or y's. All right, negative exponents. So what I'm first going to do, I'm going to distribute the negative 2 to each. And there's multiple ways to deal with these, just so you know. I'm going to do this to get 4 to the negative 2, x to the negative 8, and y to the positive 6th. Now remember, negative exponents do not mean negative numbers. I can write this as the reciprocal with the positive power. Okay, so just like that. So notice that these are actually going to move to the denominator of my answer. So they're going to the other side of the fraction line. And the y to the 6 is going to remain in the numerator when this is all multiplied out. So this is not simplified yet. Simplify, ask yourself, is there any operation that I still have to do? Yeah, I still got to multiply all of these. So I've got y to the 6th divided by 4 squared is 16, and x to the 8th, that's your final answer. Okay, over here, a couple things that you could do. First thing that comes to mind, you're dividing two numbers and these have the same base, so just subtract your exponents. 5 to the, and then negative 4 minus 9, that gives me a positive 5. You could have also rewritten this as 5x to the 9th divided by x to the fourth. So really they swapped places because this was negative in the numerator, so then it came down here. This was negative in the denominator, so it moved up here. But then you're still at the same spot. You still have to simplify your x's. 9 minus 4 gives you the 5, so you still end up at the same spot. Okay, I've got another power of a product. Couple things you could do. I could distribute the 2 to everything. Some of you guys were doing that in class. I could also simplify the parentheses first and then take care of the exponent. I'm going to do the simplifying inside the parentheses first. So when I do 4 minus a negative 2, that gives me a 6. So x to the positive 6. Negative 4 minus 4, that gives me, or sorry, negative 7 minus 4, that gives me y to the negative 11. And this is still all being raised to the second power. Okay, now I'm going to distribute again. So I've got x to the 12th, y to the negative 22nd. Okay, and if it helps if I write this all out, this is x to the 12th times 1 over y to the 22nd. So I made it positive by doing the reciprocal, which altogether is just x to the 12th divided by y to the 22nd. So that's your final answer. So notice that all of my final answers with negatives are not actually my final answers. I take it a step further. All my final answers have positive exponents. Okay, and number 8. I have a bunch of things being multiplied together. Be careful. Just because you see parentheses does not mean that you are multiplying your exponents. Parentheses just mean multiplication. This is not the same thing as this, where you have a power to a power. These are just two things being multiplied together. So what I see is 1/10 and 5/2 being multiplied. So that gives me 5/20. I have x to the 8th and x to the negative 3. That gives me x to the 5th. And then I have y to the negative 5, y squared. So all I did, negative 5 plus 2 gives me negative 3. So all I did was add my exponents. Okay, I'm going to simplify. 5 over 20 goes to 1/4. X to the 5th remains the same, and y to the negative 3 becomes 1 over y cubed. So put it all together. This becomes, it looks like I got x to the 5th divided by 4 y to the 3rd. Final answer. Okay, so that's pretty much all your exponent rules. Don't forget that anything raised to the 0 power is equal to 1, not 0. So big takeaway there, negative exponents don't create negative numbers, and anything to the 0 power is 1, and make sure you guys are keeping track of when you multiply and when you add your exponents. Okay, make sure, so I'm going to do number 10 as an example. When you're trying to simplify something like this, I've got 3 binomials. Be careful when you're distributing your negative and make sure you're distributing it all the way through. So for example, I've got x plus 1, distribute your negative, minus x plus 2, so it's changing to the opposite. Okay, and then I got another negative to distribute, minus x minus 3. Okay, then from there we're going to combine our like terms. So I've got x, negative x, and I've got 1, 2, and negative 3. Okay, my x's are going to cancel right here. Here's x and a negative x, so I still have a negative x here. And then I got 1 plus 2 is 3, minus 3 is 0, so your final answer is negative x. Okay, we had a question like this, or very similar to with the double brackets on our quiz, and some of us struggled a little bit with that. Clean up your parentheses first. Think of your order of operations. You want to clean up the inside part and then take care of the outside part. So I have 5a minus 3a plus 6 minus 3, and that's still all being squared. So all I did was distribute the negative 3. Okay, from there I'm going to combine some like terms. So I've got 5 minus 3a, that gives me 2a, and 6 minus 3 gives me 3. So this is still all being squared. From here, this is the same thing as saying, and I'll just use regular parentheses now, 2a plus 3 times 2a plus 3. So don't distribute that negative. That is not what you do when there's a sum. That's only if it's a power to a product. this is times itself twice. So you're going to FOIL like you normally do. So I've got 2a and 2a. That gives me 4a squared. I've got 6a. I've got another 6a. And I've got a 9. So altogether, it is 4a squared plus 12a plus 9. All right, cube roots. I told you guys in class that if you don't know your cube roots, that's okay. Just make yourself a quick little table. Make sure you're knowing 1 through 5. And these can also be negative, just so you know. And that's going to come into play in number 17. And that's because, think about, say, any negative number, maybe -1. -1 times itself 3 times is -1. So if you're looking for the cube root of -1, it's just going to be -1. So the cube root of -8 is going to be -2. So these can also be negative. They're not like square roots. Okay, so that all had a purpose. You will notice in number 17, I have a -3 underneath the cube root. So I'm going to rewrite this. Whoops. I'm going to rewrite this. I've got -3, cube root of -1, and then I still have the 3 underneath the cube root sign, plus 2. And then I got to figure out what factors of 162 give me, or what factor of 162 is a cube root. And it is 27 and 6. And you guys know how to find factors in your calculator. Okay, and then plus 3 cube root, now factors of 81, that's also going to be a 27 and 3. So 27 and 3 gives me 81, 27 and 6 gives me 162, and -1 and 3 gives me -3. Okay, so now I'm going to simplify. So I've got -3 times -1, because that's the cube root of -1, times the cube root of 3, plus 2 times 3, cube root of 6, plus 3 times 3, cube root of 3 still. Okay, so I've got 3 cubed root of 3, plus 6 cubed root of 6, plus 9 cubed root of 3. And some of you guys stopped there. Be careful, you can simplify further. These all have the same index, and these two have the same radicand. So I can rewrite this as 12 cubed root of 3 plus 6 cubed root of 6. So I combined my numbers with the same radicand of 3. Okay, we got another cube example at 20. So I've got the 3 halves in front. That's fine. That's going to just multiply. So I have the 3 halves still hanging out here. I need factors, or a factor of 32 that is a cube root, or is a perfect cube. So 8 and 4 gives me 32. 8 is a perfect cube. So I'm putting it in my first radical. I'm going to put the x to the third in the first one because 3 is divisible by 3. And y to the 6th and y are getting split up because y to the 6th, the 6 is divisible by 3, so I can take the cube root of it, and my leftover y is in the second one. So this is everything that I can't take the cube root of. Okay, simplify. So I got 3 halves times cube root of 8 is 2. Cube root of x cubed is just x, and cubed root of y to the 6th is y squared. And you can get that just by dividing your exponents by 3. Oops. Okay, and then don't forget to multiply these coefficients. So I've got 3 halves times 2, that's just going to give me 3. So 3x y squared cube root of 4y. Okay, for something like this, you guys have seen this not only in Algebra 1, but also in geometry. When we're going to rationalize these, we're trying to create because this is a square root, I'm trying to create a perfect square so that I can take the square root and get rid of the radical in the denominator, because I can't leave it like that. So, thought process is I can take 12 and turn it into 36. 36 is a perfect square. So I'm going to multiply the top and the bottom by radical 3. So this gives me radical 45 divided by radical 36, which is a perfect square, so that's my objective there. So I've got radical 45, which can split up into 9 and 5. And radical 36 is just 6. This becomes 3 radical 5 divided by 6. And don't forget, you can simplify even further. 3 and the 6 reduce to 1/2. So I've got radical 5 divided by 2. Okay, similar process here. I'm going to create a perfect square out of this radical 8. So I'm going to multiply by radical 2 on the top and the bottom. 2 and 8 gives me 16, and that is a perfect square. Don't forget, this radical 2 has to multiply everything here, not just the 3 radical 2. You're multiplying the entire numerator. So you have to distribute. So I get, in my numerator, radical 6 plus 3 radical 10. Notice I'm multiplying the radicals underneath the radical. And divided by 2 radical 16. Okay, 2 radical 16 is the same thing as 4. And 4 times 2 gives me 8. So this gives me 16 in my denominator. Or excuse me, 14. The square root of 14 is 4. And 4 times 2 gives me 8. So not 16, 8. Again, that's because that is 4. 4 times 2 gives me 8. And then I still have the radical 6 plus 3 radical 10 in the numerator. And neither 6 or 10, those can't be broken up any further with perfect squares. That's your final answer. Okay, so now if I look down here at number 25, I've got 2 minus radical 7 in the denominator. So I can't just create a perfect square as easily as I did these examples up above. This is where I have to multiply the numerator and the denominator by the conjugate of the denominator. So I'm looking at 2 minus radical 7. The conjugate, I'm just changing the sign in between. So it is 2 plus radical 7. Again, recognize that these are going to have to be FOILed in the denominator as well as the numerator. Okay, so I'm going to do the numerator first. So I've got 1 times 2, that gives me 2. Then I got 2 radical 7 plus radical 7 plus, and then radical 7 times radical 7 is radical 49, or 7. My denominator is really nice because the conjugate is what gets rid of my middle terms, or my inners and my outers. So I've got 2 and 2, that gives me 4. Okay, my middle terms give me, my inner and my outer, I got 2 times negative radical 7, so it's 2 negative radical 7, positive 2 radical 7, so those are going to cancel each other out, so I'm left with minus radical 7 times radical 7, which is radical 49, or 7. Okay, I'm going to clean this up a bit. So I've got 2 and 7 gives me 9. 2 radical 7 and radical 7 is 3 radical 7. And my denominator is negative 3. The 9, 3, and negative 3, each of these can be divided by negative 3. So this results in negative 9 minus radical, whoops, sorry, I forgot to divide. 9 divided by negative 3 gives me negative 3 minus radical 7. And that is completely simplified. Just to get you started on 24, again, you have a binomial in the denominator, so you're going to have to multiply by the conjugate, which is going to be 2 minus radical 2. The denominator is going to be FOILed, and again, you're just really completing or figuring out the first and last terms because your middle ones are going to cancel. In the numerator, I just have 3 times each of these, so just distribute. So recognize the difference. The numerator is just distributing the 3 there to each. This one you have to FOIL. Okay, if I come down here to 26, I told you guys in class that if you're proving something, you're working each side separately. So just draw a line down the middle to remind yourself that you are doing this. Please do this on the test. Okay, so I'm going to start on the left-hand side here. So I've got x plus y squared. So this is the same thing as x plus y times x plus y. Okay, maybe I'll actually move this over a little bit just to give me some more room. Okay, minus 3 times x minus y times x minus y. Okay, FOIL it. So I've got x squared plus 2xy plus y squared. So first outers and inners and lasts. Okay, and then I got minus 3 x squared minus 2xy plus y squared. And that's just from FOILing. Okay, I'm going to take care of this negative 3 and distribute it to each term. So I've still got the x squared plus 2xy plus y squared out front, but then this changes to negative 3x squared plus 6xy minus 3y squared. Okay, now I'm going to combine my like terms. I see some x squareds, I got some xy's, and then I have some y squareds. So I get x squared minus 3x squared, that gives me negative 2x squared. I've got 8xy. And then lastly, I get minus 2y squared. So you'll notice that this ended up equaling this. So what I'm going to do is just rewrite this down here below. So I have negative 2x squared plus 8xy minus 2y squared. So this one happened to already be really simplified nicely for you. It won't always be that way. I may have to simplify this to get it to the same thing. As long as in the end, you guys showed all your work and factored and all that good stuff, or excuse me, distributed and all that stuff, these two are equal, then we have a proof. So we just showed that the left-hand side is equal to the right-hand side. These two sides simplified to the same polynomial. Okay, divide using any method. Just something to touch upon quickly. I know I'm not going to do any of these, but recognize that this is a good candidate for synthetic, because this is a linear term or a linear function with a leading coefficient of 1. This one is not. Do not do synthetic with this one because I have it is linear, but it has a leading coefficient of 3, not 1. This one is a quadratic because I have 2x squared plus x plus 2. This is where you're going to use your tabular. And just remember that when you're setting up columns and rows, the rows is always equal to 1 more than the degree of the divisor. So row is going to equal 2 plus 1, which equals 3, based on this example. And the columns are going to be equal to x cubed divided by x squared, which gives me x to the first, and 1 plus 1 equals 2. So just for your setup and just in general, make sure you're filling in terms and all that stuff. So check the answer key for those. So you guys are pretty good on those, though. Okay, for 28, using factor and remainder theorem. So you can't just use synthetic on these. Explain if the given binomial is a factor of the given polynomial. So I have a 4th degree polynomial and I'm trying to divide it by this, and I want to find out, is this a factor? And I can only use the factor and remainder theorem. That means we're going to plug in the root of this factor, so p equals 2, or of this binomial. I'm going to plug 2 in everywhere I see p in the polynomial. So I've got 2 to the 4th minus 8 times 2 cubed plus 10 times 2 squared plus 2 times 2 plus 4. And I want to find out what that simplifies to. So 2 to the 4th gives me 16. This gives me negative 64. This gives me 40. 2 times 2 is 4, and then I still have the 4. If you were to plug this in your calculator, find out what it is, blah, 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 you get this all equal to 0. Now remember, in the factor and remainder theorem, if you're plugging in the root of this binomial into this polynomial, so I'm plugging 2 in, this is the remainder. And if something is a factor of another polynomial, then the remainder would be 0 if you did the division. So this is just a really good shortcut instead of actually dividing and see, does it divide in, does it not, and so forth. So just you can plug that in. And then it says explain if it is. So you would say, yes, it is, because the remainder is 0 for p of 2, which means I'm just, plugging in 2 everywhere I see a p. Okay, b would be the same thing, but recognize that this is x plus 6, so that means you're going to be plugging in -6 everywhere you see 5. See if you get a remainder of 0. If you get something else, then it's not a factor. Okay, so this ties into our example 29, and this is the last one I'm going to cover in the video, where we're trying to find the value of k in this cubic polynomial, so that when I divide it by x minus 2, I have a remainder of 44. So we just said previously that if I were to evaluate this at the root of this binomial that I'm trying to divide it into, if I evaluated it at 2 and plug it in, using the factor and remainder theorem, what it equals is the remainder. So if I do k plus 2 minus k, when I evaluate this, finding what k is, this should equal the remainder, which I want to be 44. If I wanted it to be a factor, then I would set it equal to 0 because I want the remainder to be 0 using the factor and remainder theorem. So 2 cubed is 8. Okay, and then from here it's really just a solve for k. So I've got 2 plus 7k is equal to 44. 7k is equal to 42. So divide by 7, k must equal 6. And there we go. So this is the conclusion of the review. So if you guys have any questions, feel free to Witsmail me over the next couple days, and I will be in school early Thursday, the day of the test. So come on down. All right.